Yes. How are you today? This chemical reaction is one of the most important subjects of the chemistry, and we are gonna do some reaction, and we have reactants, and we have some products, and chemical reaction is the process, we can say, by which a chemical change occurs. Nothing happens when substances are mixed. Each retains its original composition and properties. We need some evidence before we can say that a reaction has occurred. What do you think about what are these evidence? What can be these evidence? Can you say me? If there is a reaction has occurred about another. We have some evidence. What are they? Please say something. Yes, I'm waiting. Change in color. Yes, that's right. The gases you have. Yes. What else? What else? Maybe burning reaction. Yes, we can say the burning reaction, and this is maybe evaluation of gases, or what else? What else? The types of physical evidence. These are the physical evidence. For example, a color change, or occur a gas, or evaluation or absorption of heat. And then what else? Maybe one more. From liquid to the solids. Change in shape. Maybe change in shape, deformation is, we can say this is a change in shape, maybe. Yes, reaction to litmus. Reaction to litmus. Litmus, what is that? Precipitate, yes, that's right. I'm waiting that answer. Formation of a solid. This is, we can call that precipitate within a clear solution. And we are all aware that, for example, iron here, just iron, rust, for example, and natural gas burns. These processes are chemical reaction. For example, iron rust, maybe this is the chemical reaction, and gas burns also is the chemical reaction. And many chemical reaction occurs in solution. This is the aqueous solution generally. And we will also consider solution stoichiometric and introduce a method of describing the composition of a solution called solution molarity. And chemical reaction, if we want to describe this chemical reaction, we often take a microscopic view and focus on the entitized atoms or ions or molecules that make up the substance involved. Yes, Amir Mohammed. I think you will say something. That's right, or this is the wrong thing. Amir Mohammed, hold your finger, and then will you say something, or this is the wrong sign? Yes, I am going. I gone. But when doing Okay, I understand. When doing chemistry, we often think of reactions is more macroscopic terms, because in the laboratory you can see that we handle quantities of substances, grams or liters or milliliters or milligrams that can be easily measured or manipulated. Yes, we are seeing here the picture, the right one, a chemical reaction. And chemical reaction, we call this is the process, one set of substances, and these are called reactants. And these reactants is converted to a new substances, and we call that this is the products. In other words, a chemical reaction is the process. This is the chemical change occurs. Look at here in the picture, we have a no color aqueous solution, and this is the yellow solution we have. And then this is the silver chromate. This solution is the silver chromate, and one aqueous solution is that one. I am so sorry. This is the silver chromate precipitation, and one aqueous solution of silver nitrate. This is the non-color silver nitrate. Yes, my hand is here. Yes, one aqueous solution of silver nitrate. That one is no color, and that one potassium chromate, and potassium chromate color is yellow. When you put that potassium chromate solution in the silver nitrate solution, this maybe red or brown precipitate occurs, and then we can call that there is a chemical reaction here. And the appearance of the red-brown, here the red-brown solid, this is the silver chromate, and this silver chromate is the product, and other one, the reactants. Reactants are what are they? This is the silver nitrate, and this is the potassium chromate, and then you can get that products is the silver chromate. Don't forget that. This is the physical evidence of a reaction. And yes, some of types of physical evidence, don't forget that these evidence, because there is these are the important evidence. A color change, yes, we have the color change, and then we have the precipitates here, the solid one, red, brown, silver silver chromate products, and evaluation gas, evaluation or absorption of heat. And then this is the second example of occurs of that chemical reaction. What is that? This is the evaluation of a gas. For example, when this is the copper penny, and copper penny reacts with the nitric acid. You know that the nitric acid is very strong acid, and reaction occurs. The red-brown gas, here the red-brown gas is evolved, and that we can say there is a chemical reaction. Consider the reaction of colorless nitrogen monoxide and oxygen. There is a arrow here actually. To form red-brown nitrogen dioxide gas, and a reaction that occurs in manufacture of nitric acid, we can say that. But never we write this reaction like that, because only the naming of chemical formula we don't write while we're writing chemical reaction. Only we always use these chemical reactions formula. Okay, don't writing like that. This is the important thing. For example, here the nitrogen monoxide. Check here. Yes. Just yes. That is one. And for example, nitrogen monoxide and then oxygen gives us a nitrogen dioxide. To complete the shorthand representation of this reaction, we must do two things. Don't forget that these two things very important. First of all, the coefficient. You know that the coefficient required to balance a chemical reaction, and we call that this is the stoichiometric coefficient. And this stoichiometric coefficient very important of this subject, because while this reaction occurs, the left one and the right one of elements number always must be equal. For example, the nitrogen here, the left one, the nitrogen is the only one, and the right one only one. That's okay. This is not there is no any problem. But if we check the oxygen element here, the one from the from nitrogen monoxide, and then from oxygen we have two oxygen. Collect these oxygen, we have only 3 oxygen for the left one. But here the right one, check here, only we have 2 oxygen, so we have to equal that oxygen both of sides. For example, if we put here the 1 divided 2, that means 0.5 multiply with the 2, that means only 1 oxygen. And we write here, what's that? 1 divided 2 coefficient here, for example, yes. And then check this oxygen number. We have only 1 oxygen, and we have only 1 oxygen. Here the 2 oxygen, 2 oxygen, and this oxygen is equal to both sides. Don't forget that this is the important thing. Balanced is very important in the chemical reaction. And then don't forget that atoms are neither created nor destroyed in a chemical reaction. Okay, always you will do some, you will put some coefficients before in front of this chemical formula, and balance the numbers of atoms of each kind of both sides of expression to obtain a balanced chemical reaction. In this step, in this second step, the coefficient 2 is placed in front of formulas here, that one, NO and NO2. This means that 2 molecules of NO are consumed and 2 molecules of NO2 are produced for every molecule of oxygen consumed. In the balance equation, there are two nitrogen atoms and 4 oxygen atoms on each side. Always we do that these coefficients exact numbers. If we want the exact number, whole number, or we can say, we have to multiply with 2. Okay, if we want to multiply with 2, always these effects, and these effects, all of these chemical formula affects that coefficient, and we can write that reaction. That means 2NO and then only 1. If there is no any numbers, that means only 1 oxygen, and then we produce 2 nitrogen dioxide. And balanced equation, that's right. If we if you want to check that balance equation is okay, you will do, this is only 2 nitrogen and here 2 oxygen, and then this is the 2, that means 4 oxygen on the left, right. On the right side we have 2 nitrogen and 4 oxygen. That is the equal. I think this is clear, because this is the important thing we will do in the problem, this balanced equation. So you must understand this subject. Is that clear? Yes. Yes, these are some rules of balanced equation, chemical equation. Don't forget that these rules. First of all, if an element occurs in only one compound on each side of equation, try balancing this element first. Don't forget that. And always you do the last element, hydrogen and oxygen. Don't forget that. This is the last elements. Okay, last elements equation will be. When the second one, when one of the reactants or products exists of the free element, balance this element last. For example, oxygen. Okay, this is the free element, and you will do the balance equation this element last. Don't forget that. This is important rules. In some reaction, certain groups of atoms, for example, these can be polyatomic ions, remain unchanged. In such cases, balance these groups as a unit. It is permissible to use fractional as well as integral numbers. Yes, I said to you, as coefficients. Generally, we want to integral numbers, the whole numbers. Don't use the fractional numbers. At times, an equation can be balanced most easily by using one or more fractional coefficients, and then, if desired, clearing the fraction by multiplying all coefficients by a common multiplier. Don't forget these rules, very important to complete this balance reaction. Yes, for example, check that one. This is the example. Ammonia and oxygen can react in several different ways, including the following, and balance the equation in this reaction. Here, there are 3 kinds of atoms. We have 3 kinds of atoms. What are they? This is the nitrogen, hydrogen, and oxygen. The chemical reaction, the chemical equation is balanced only if it is balanced with respect to each kind of atom. First of all, I said to you, the last elements will be hydrogen and oxygen, and then the most last element will be free element. What is that? This is the oxygen. So if you want to arrange these elements, first of all, you have to look nitrogen, and then hydrogen, and then the last one, oxygen. Yes, let's check the left one. We have only one nitrogen, but here the right one only 2, so we have to write here the nitrogen in front of only 2. Okay, and then check the hydrogen. Left we have hydrogen 2 multiplied with 3, that means 6 hydrogen, and the right one we have 2 hydrogen. If you want to 6 hydrogen, we have to multiply with 3, yes, and we write 3 in front of the water. Yes, and the last one, the last element will be the oxygen. Check here, the left 2, the right 3. So if we write here the 3 divided 2, that means here 3 oxygen. Okay, and then please check that reaction. This is equal or not equal. 2 nitrogen and 6 hydrogen and 3 oxygen. And the right one, 2 nitrogen, 6 hydrogen and 3 oxygen. So we don't want the fractional coefficients, so we can multiply with what's that, with 2, and this affects all of these formula. And here, if we want to write the second reaction, the 4 ammonia, and what's that? This is 3 oxygen and 2 nitrogen, and we have 6 water. If you want to check, 4 nitrogen here, 12 hydrogen, and this is the 6 oxygen. Here check 4 nitrogen and 12 hydrogen, and not plus here the 6 oxygen. Yes, that's the equal. This is the equal, and this reaction is right, and this reaction is right also. But the coefficient, we don't want to fractional, so we write the whole number. I think this is clear. I will pass. Yes, this is the explanation of yes, this section will be included in the exam. That's right, of course. This is the explanation of how we equal that balance equation in chemical reaction. This is the explanation, so I explained to you how we do that. Yes, this is your homework, and this is example. What is the example? Liquid triethylene glycol oil. Yes, this is the liquid triethylene glycol is used as a solvent and plasticizer for vinyl and polyurethane plastics. Write a balanced chemical equation for the combustion of this compound in a plant full supply of oxygen. A ball and stick model of triethylene glycol is shown here, only shown here that to forcing to you. Yes, this is how chemical is that. This is organic or inorganic chemistry, and then if you want to combust with oxygen products, what are the products? Yes. Actually, I explained that the last subject. What is that? This is, yes, Bihter, thank you. This is organic chemicals. Why? Because there is a loss of carbon here and then hydrogen. And I said that if a chemical formula have the carbon atom, that means the organic molecule, but except 2 molecules. I said to you, I don't say now. Yes, if you want to combust with oxygen, we have only carbon dioxide and water. And then please balance that reaction. First of all, check how many type element we have. This is carbon, hydrogen, and oxygen, 3 type element we have. Let's do that for, first of all, carbon atoms. We have only 6, and here we should have 6 carbon atoms. And then look at hydrogen. This is the 14. If you want to 14, I have to multiply with the 7. And then the last one is the oxygen. Check here. This is the there is that comes from here 12 oxygen and comes from 7 and then collect that one. This is a 19 oxygen. Okay, 19 oxygen, and we have to here 19 oxygen, but here the 4. So if we want to put that here coefficient, these carbon and atoms affects that coefficient. So if we want, if I minus with that oxygen from here, yes, 4, and then I need 15 oxygen from here. So I write here 15 divided 2, that means the 15 oxygen I have. Check please. This is here check for elements. This is 6 carbon atoms, 14 hydrogen atoms, and here the 4 and here the 15. We have 19 oxygen. Check here. This is the 6 carbon atoms and 14 hydrogen atoms. Here the the 19 oxygen. These elements always equal, and this balanced equation is right. And if I don't want to write the fractional number, fractional coefficient number, I have to multiply with 2, and then the new reaction, new balanced reaction will be like that. This is a 2 triethylene glycol, and then 15 oxygen, and then 12 carbon dioxide, and then 14 water. That's it. This is the right, and this is the right. Only this coefficient whole number. Is that right? Is that clear? I pass. Yes, this is explanation of how we do this balance, and this is your homework. Yes, states all matter. States all matter. For example, always we have to write that matter. That states all matter here. For example, triethylene glycol, for the example that I did, triethylene glycol is liquid, so we write here differences in the parentheses L, that means the liquid, and this is the oxygen, the gases. This is the carbon dioxide, is the gases, and the L is the liquid, means, and these facts are inconsequential if our interest in only balancing an equation. At high combustion temperature, water is represented as gas phase, okay, not liquid. In the gaseous phase at the high combustion temperature. Don't forget that. But when the reaction products are returned in the initial temperature, the water condenses to the liquid like that. This is the liquid of water. Chemical. Yes, chemical here. Chemical equation and stoichiometric. Stoichiometric is very, very important. Stoichiometric coefficient, actually, we can say. Coefficient in the chemical equation. Here, the hydrogen gases and oxygen gases combine, and then they will give us to water, liquid water. And always that means this is 2 molecule, 2 molecules hydrogen, and then only 1 molecules oxygen, give us 2 molecules water, and that means this is the X means this is the Avogadro numbers, so we call here the molecules, and always we used and always we say this is the mole. These coefficients always means that this is the mole. That means the 2 mole hydrogen, 2 moles of hydrogen are consumed for every 1 mole of oxygen consumed, and gets produced 2 mole water. Don't forget that. And the stoichiometric factor relates the amounts on a mole basis. Don't forget these important, and any substances, two substances involve a chemical reaction. So a stoichiometric factor is a mole ratio. Don't forget, in the following examples, we will do stoichiometric factors are printed with a color here. Yes, the coefficients in the chemical reaction allows us to make statement like 2 moles of water are produced for every 1, 2 of oxygen consumed. These statements, we can call that this reaction read, okay? This reaction reads like that, these statements. Don't forget that. Always we read these reactions. That means the 2 hydrogen give us 2 water molecules like that. Yes. Let's doing an example. For example, yes, again chemical. This is the triethylene glycol, and combustion 2.72 mole of triethylene glycol. How many moles of carbon dioxide are produced? First of all, you have to do balance of this combustion, and then you will do that example. You will do that this calculation. So you have to write that one, and then we did that actually. Carbon dioxide, and this is water. Yes, this is 6, and this is 7, and this is 15 divided 2. Yes, this is our reaction, and we can they ask us the carbon dioxide. This is important. This water not important, and this oxygen not important, because the oxygen uses excess, so we don't use that. That one, the triethylene glycol, and that carbon dioxide is very important, and they ask us mole. This is very easy, and they give us the mole. So if you use the coefficient, that means the 1 mole, because there's no any numbers, that means the 1 mole. 1 mole triethylene glycol give us 6 mole carbon dioxide, and we have only that one, 2.72 mole triethylene glycol. How many carbon dioxide give us? Okay, only you multiply that. This is proportion. 6 multiplied as 2.72. Yes, this is 1632. 1632 mole carbon dioxide. That's it. This is very simple, very easy, so easier than the other problems you will see. Yes, this is that one. This is explanation of how we do that. Yes, they used here, the whole number. So they multiply with 2 and write 2, 15 like that. Okay, this is only a simple one. Yes, these are your homework. Actually, there is a coefficient here. but I won't give you these coefficients in the exam. Don't forget that. Okay, I won't give you these coefficients. You will put, and then you will calculate that reaction. Okay, that's clear. I think this is important thing. Yes. This is example, again triethyl glycol, but at that time, this is the gram. This is the mass. Mass, that means the gram. So you have to do some conversion here. Yes, some conversion here. And which one? I repeat, if you listen these recordings again, you will. Okay. This is yes, this is the mass, not mole. So we have to write first of all that reaction. You know that here our reaction. We cannot do anything by using mass. Always using mole, very important, and calculation. In the calculation, the mole unit is very important. The mass, not important. The mass, with the mass, you don't think. Anyway, yes, this is hydrogen. Yes, I do again the same thing. Yes, water. What's that? This is, I think, is whole number I will write. And this is the 15 and this is the 2. Yes, this is our reaction. First of all, you will do that. And then you will read this reaction. What is that? For example, the triethylene glycol. Triethylene glycol, this is the gram. So you have to convert that. You have to convert that to mole. Okay, if you want to convert that one, this is the N formula. This is M mass, Ma, or MM. This is molecular mass. Okay, molecular mass of triethylene glycol. What's that? For the carbon atom, this is the 12 gram divided mole, and for the hydrogen 1, and for the oxygen 16. Please do that, this molecular mass, and then tell me. This is, yes, if you want to find that mole, you will write this. This is 4.16 gram. And what's that? The triethylene glycol. Is there anyone calculate that? Is there anyone calculate that? I will check my notes. What's that? This is 150 gram divided mole. Yes, that's right. And then you will find of that triethylene glycol mole will be 0.0277 mole. Yes, this is, what is that? This is mole, that triethylene glycol mole. So you have that mole. Now, please don't do that. Don't draw my board. 2 mole. Now we read this reaction. 2 mole triethylene glycol give us, they as carbon dioxide, give us 12 carbon dioxide, but we have 0.0277 mole triethylene glycol. How many carbon dioxide? How carbon dioxide we have? This is the 0.166 mole carbon dioxide, but we found that carbon dioxide unit with the mole, but they ask us with the mass. So you have to convert that. What is the formula? N is M and carbon dioxide molecular weight, and you don't know the mass, and N multiply with the carbon dioxide. Here the mole, that mole writing here, this is 0.166 mole, and the carbon dioxide molecular weight will be 44, I think, divided mole, and 44, and you will find the mass of carbon dioxide. What's that? This is a 7.31 gram of carbon dioxide. Okay, carbon dioxide. That's it. There is lots of, not lots of, there is only two conversion here. First of all, the gram you have, and then you conversion that the mole, and then you will find the mole of carbon dioxide, and there is a conversion again, the gram. That's it. Okay, is that clear? Is it clear? I think clear. I will pass. This is your homework. Yes. How many grams of magnesium nitrate here produced by the reaction of magnesium and excess nitrogen? There is a so good example. There is an example again. Again here, tretylene glycol again. I won't do this example because the same thing, only this oxygen is different. The last example has the carbon dioxide they ask, but here they ask us the oxygen. That's it. I won't do that. This is your homework actually. Yes, this is your homework, and this example, balanced reaction example, I think. No, this is the example. Example 4.1. How many grams you will do and are consumed per gram? Yes, they ask us how many grams. Always you will do, first of all, the mole, and then a cule of the mole, and then you will do the conversion again. Yes, chemical reactions in solution. This is the important also, because always we will do that, this chemical reaction, and most chemical reaction is generally chemistry laboratory are carried out in solution. This is partly because mixing the reactants in solution helps to achieve the close contacts between atoms or ions or molecules necessary for a reaction to occur. For example, remember the second slide. Remember that this is the equation solution. For example, what were they? This is the for example potassium chromate and silver nitrates mixed these reactants, and we have this new substances. What is that? This is the silver chromate. Remember that. And here the solution, in the solution called solvent, this is determines whether the solution exists as solids or liquid or gases. This discussion will limit ourselves to aqueous solution in which liquid water always is the solvent. Generally, we use this solvent always will be the water. And other components, a solution called solids. Maybe we can write here the solution is equal solids and solvents. Okay, this is the equation. For example, sodium chloride aqueous solution. Describe a solution in which liquid water is the solvent and sodium chloride is the solute. This is the solid one, sodium chloride, and water is the solvent. And if we mix that two substances, we have the solution. What is the solution? Sodium chloride solution, aqueous solution. Don't forget. For that one, the property called molarity is commonly used. Always we are gonna use this molarity unit. Okay. Don't forget that. The molarity, and we will use in the laboratory also molarity, and defined as an amount of solute in moles per liter of solution. Okay, always the volume unit will be liters, not milliliters. Okay, don't forget that. This is the important thing. Amount of solute in moles per liter of solution. And we write here the molarite formula is equal to mole divided volume of solution. Don't forget that. If, for example, here, if that 2.44 mole urea is dissolved in enough water to make 1 liter of solution, if this solution 1 liter, that means the molar is equal to moles. Yes, molarity is equal to mole if we have 1 liter solution. Yes, this is the example of this molarity. We have 25 milliliter ethanol, and always they have to give this density because this is the ethanol and this is the liquid one. Always for the liquid, we can't weight this with the gram. Always we weight this the liter, so we have to get the density of that chemical in enough water to produce 250 milliliter solution. Please turn off your microphone. Please, Anas.
Oh, sorry.
Yes, here. Yes. So if we want to read that that unit, we have to write here like that. Actually, this is the one milliliter has 0.789 gram for the ethanol. We have 25 milliliters. How many gram ethanol we have? Okay, first of all, we will do that. If you multiply that, 25 multiply 0.79. Yes, 19.725 gram. Yes, we find that gram, and then we will do for the molarity. What is the molarity of ethanol in the solution? In that solution, we prepare that volume or ethanol solution. So molarite has mole and volume. We have the volume. This is the 250 milliliters. This is the milliliters, so you have to convert that to liters. So you have to divide it this 1000. This is 0.25 liters. And you don't know the mole, but you can find that mole from that gram. And for that ethanol molecular weight will be what is that? This is the 46 gram divided mole, and right here this N formula M, this is MA, molecular weight, or we write this is molecular weight, this is N, what is the mass? 19.725 gram, and this is the molecular weight, and right here, what is that? Divided 0.43. That's right. Yes, approximately 43 mole, and you will write that mole to here, and you will find that molarite. Yes, that mole divided with 0.25, and you will find, yes, that's right, molarite will be 1.71 molarite of ethanol. Yes, this is our values of, what's that? This is ethanol molarity. That's it. Maybe lots of calculation, but these are very easier. Yes, these are your homework, and yes, here preparing the solution of potassium chromate, I think, because this is the solution, this is the yellow one, potassium chromate always yellow color. The solution cannot be prepared just by adding this that gram potassium chromate to 250 milliliter water. Instead that, for the A, the weight quantity of potassium chromate first added to clean dry volumetric flask. This volumetric flask volume is 250 milliliters, and then for the B, is dissolved in less than 250 milliliter of water, and shake it, shake until there is no any solid, and then for the C picture, the flask is filled to the calibration mark. There's a calibration mark here. By the careful addition, maybe drop wise, of the remaining water, and we prepare our 0.25 molar of potassium chromate solution. And then you mustn't forget to write on the label in this solution name. Don't forget that. Yes, the other one. This is what mass of potassium chromate is needed to prepare exactly 0.25 liters of this potassium chromate in water. You will do that. What mass? If you use the molarite has the mole and volume. That volume here, put here, and then you know that molarite and put that molarite, and you will find the mole. Okay, and you will find the mole, and then you can pass the mole formula, molecular weight. You have to write the potassium chromate molecular weight right here, and then you know mole from here, write that one, and you will find that mass, like gram. Okay, I don't write here. I will always use this formula, or I will always the proportion using for solution that problem. That's clear or not clear? I think clear here, because always you will find the mole and then put here and then use that mole formula. And please, can you do that using that formula, and you will find that volume. This is also your homework. Yes, this is the solution deletion. This is solution deletion. Generally, we have the concentrated solution has a relatively large amount of dissolved solute. A dilute solution has a relatively small amount. Okay, small amount. For example, we have the 0.25 molar, but we prepared that from that solution. We prepared 0.1 molar, for example. So we will always use this solution formula. Initial volume is equal to final molarite, and multiply with final volume 1. Don't forget that. When a full volume of a solution is diluted, the amount of solute remains constant. If we write equation here for the initial undiluted solution, we can obtain that. Yes, this is the example of solution deletion for the solution deletion subject. A particular analytical chemistry procedure requires 0.01 molar potassium chromate. What volume of, yes, I said actually, this is so dilute or so small of amount, this potassium chromate. We have 0.25 molar potassium chromate must be diluted with water to prepare that one, that's 0.01 molar potassium chromate. You will use, first of all, you calculate number of moles that must be present in the final solution. If you want to find first of all the mole, you can calculate, but you have if you want to use that formula, you can use. Yes, the first one, the initial, you have only 0.25 molar, but you don't know how many potassium chromate you will take. This is the initial volume, and the final molarite will be 0.01 molar, and multiply with the 0.25 milliliter or liter, yes. And there is a same volume here, and initial volume will be 0.01. What is that? Milliliter or liter? What is that? Milliliter or liter? Are you there? That will be liter, because here we write liter, so you have to write that unit liter. Don't forget that these units are very, very, very important. Yes, this is also another way of solution that problem. And then this is your homework. And for example, this is our solution, concentrate solution actually, concentrate solution, and preparing a solution by dilution like that. A pipette is used to withdraw a 10 milliliter sample of from, what's that? This is the 0.25 molar of potassium chromate, and then put that volumetric flask and fill the water until the mark volume. Okay, that one important, and the water is added, bring the level of solution to the calibration mark. Yes, this is the last slide, and this last slide says potassium chromate and silver nitrate give us, actually that is related to it. That is related with the first slide. What is that? The first slide. This is the potassium chromate. Yes, here. Yes, we will do that problem for that one. This is here. Yes, this is silver chromate precipitation, silver chromate, silver nitrate, and potassium chromate. Check the last one, potassium chromate, and this is the aqueous solution, silver nitrate aqueous solution, and we have the solid precipitation, silver chromate, and potassium nitrate aqueous solution. Again, I said I won't give any coefficients. Okay, you will put these coefficients while doing your problem in the exam. And here, first of all, a 25 milliliter pipette full of 0.25 molar potassium chromate is added to an excess silver nitrate aqueous solution. What mass of that solid precipitation, what's that silver chromate, will precipitate from the solution? Don't forget that you will use these, coefficients while solving that problem. First of all, if you use this reaction, chemical reaction, and this coefficient, think about that. You will use the mole. So you have to do that. First of all, potassium chromate mole. Potassium chromate molarite formula is N divided volume, and this is the milliliter. You have to convert that the milliliter, 0.0123, yes, 0.025 liters. You will write that volume here, and you know that molar, and you write that molar. Yes, please, if you write here, you will use the moles of potassium chromate. That will be 6.25 multiply that 3 mole, and then you will read this reaction. If they give us the potassium chromate, but they ask us silver chromate, check that coefficient. This is the one. That one is only one. This is equal. So that mole is equal silver for the silver chromate. Okay. This is the mole of silver chromate. The same thing. And then they ask us the mass. So you have to convert that the N formula. You know that M divided M molecular weight. Molecular weight of potassium chromate will be 331 gram divided mole, and that mole you will write here, and you will find the mass of potassium chromate like that. That's it. This is the first, actually, first way of solution that problem, and this is the second way, and this is my way. The third one, my way. This is actually first and third way is the same actually, and you can do that easily, that problems. That's it for that week. Until here, you are responsible in the exam, and I will do some explanation in the email for exam maybe. Not only Okan mail, but also Blackboard. I can send the email. Okay, that's it. Is there any problem or is there any question? Next week there is no any class, okay? Because we have lots of exams. Next week you have only exam. Yes, is there any problem or is there is no any question? You can go. Thank you so much. See you not next week, the other next week. Yes, will be May. Yes, that month will be May. Okay. See you.